For this video, we're looking at the function f of x equals x to the fourth minus 4x cubed, and we're checking to see on what intervals it's concave up, concave down, and does it have any points of inflection, etc. So to talk about concavity and points of inflection, we're going to go to the second derivative. To get there, you have to start with the first derivative, and this is just power rule. We're starting with an easy example. So 4x to the third minus 12x squared. Then I'll go to the second derivative, f double prime of x equals 12x squared minus 24x. So when I'm looking for concavity, I'm looking to see whether the second derivative, is positive or negative. So the first thing I would do is actually set it equal to 0, which divides positive and negative numbers. So I'm going to factor to solve. I can pull out a 12x, and I'm left with 2x minus, x minus 2 equals 0. So I set my factors equal to 0, and I have x equals 0 and 2 for possible points of inflection. Now I know for a point of inflection that my second derivative has to be 0 or undefined, but if the concavity does not change at these points, they are not points of inflection. So I'm going to draw a number line and put my important values of 0 and 2 on the number line, and I'm checking the sign of the second derivative. If I was checking for maxes and mins going through the first derivative test, I'd be looking at the signs of the first derivative. So I'm going to take a number to the left of 0, like negative 10, and I'm going to plug it into the factored form. So 12 times negative 10 is a negative, times negative 10 minus 2 is a negative. I know a negative times a negative is positive. So my function was concave up. A number between 0 and 2 is 1, so 12 times 1 is a positive, 1 minus 2 is a negative. Positive times a negative is a negative, and my function was concave down in that interval. After 2, you can pick any number you like, say 10. 12 times 10 is a positive, 10 minus 2 is a positive times a positive is positive, and we're back to concave up. So if someone asked me on what intervals was this function concave up, concave down, I could say it's f of x is concave up on 2 intervals. I'm going to say from negative infinity to 0 and from 2 to infinity. And I know that because f double prime of x is greater than 0 on those intervals. So I know that f of x is concave down on the interval 0 to 2. I know that because f double prime of x is less than 0 on that interval. I also know that f of x has 2 points of inflection. They are at x equals 0 and 2, and I know that because f double prime of x changes signs. It doesn't matter if it changes from positive to negative or negative to positive, but it changes signs at x equals 0 and 2, which means your concavity changes, which means they are points of inflection. So that is that problem finished.